guys' definite interval using a definition of a definite interval involving the limit of a real sum.
Okay.
Only because it's a final exam, exiting the typical first semester practice course.
No, I understand that, but we only have an hour and a half to 2 hours to do it, and testing us on everything.
Well, he's gonna stay late.
I hope you're planning bringing a sleeping bag and a tent.
So,
I'll bring the Red Bulls.
What was it, 5.1?
Yeah, no, it's not. 5.1 gives 31 not 4.8.
Well, you guys, I'm definitely clearing my schedule next Wednesday night. You know, you want to stay late, go for it. I'm okay with that. And on the other side of the coin, you guys got to expect this to be as horrible as it sounds, it's got to be a lottery. I mean, you guys are going to come into class, and you should expect to be tested on everything. And I guarantee you, I will not test you on everything. I don't have the time. However, one thing you could do is go back to the first 4 exams, identify what was being emphasized in the first 4 exams. You could ask yourself, what would be a decent question in a final exam situation? Like, for example,
I like examples.
what's its derivative?
secant squared x.
That'd be a good final exam question.
So, one thing you never really went over too much in class, but we did on our homework, was the infinite limit proofs. Should we spend a lot of time on that, or?
You know, I confess, that is correct. I spent more time on the epsilon delta proofs,
Yeah.
personally.
So, should we be spending a lot of time on the infinite limit proofs, or
No,
spending more time
I
on
think
delta epsilon?
emphasizing epsilon delta proofs is more
Okay,
appropriate.
okay.
But you guys have a point. That's not a good final exam question, is it? I mean, you're not putting anything together. You're not showing me that you can synthesize. And so expect the final exam question to be incorporated in something. Like, for example, optimizing in a typical application problem, or dealing with a related rates issue. Do you see my point? I'm not trying to somehow whittle down the final exam. I'm just saying intellectually you understand that a final exam question is going to be not one of those,
Yeah.
right? So putting things together.
A couple of those, though.
Oh, that wouldn't be fun. You wouldn't feel good about yourself after taking
I feel great.
All right. You guys, before we get started, any questions? Ooh, is the homework going that well?
Oh, actually, the spring one you could do.
The spring one.
Yeah. So I think it's the 81 of chapter, let's see, whatever the last chapter in Coral is, 4.8, yeah.
You know, Brad, I'm still lost. I'm sorry.
It's number 81. Oh, not the spring, the flow rate, sorry. The one below the spring. I was looking at the
So
spring.
number.
81, the
Gotcha.
flow rate.
In this
Yeah.
4.8.
Yeah.
She also do 23,
So 23 and 48, or 23 and
81.
81.
And maybe 30, or the even one from, or 32 from 5.1, so I can make sure I did the right thing.
So 23.
32 from 5.1, yeah. Oh, I think he does.
Well, you guys, how about doing this? What can you possibly say about the evaluating this interval instead? I mean, what do I do?
You
Added
one
one and
to the power and then divide it by the power.
So adding 1 to the exponent divided by the new exponent. Got it. What's next?
add a constant,
What's that? Add.
C,
Add.
constant.
I think that's wrong.
Yeah, how about adding in, how about getting rid of something like.
You get rid of the little integral sign and the dx.
Okay, I think the process of anti-differentiating that piece in the integrand's position is the process of removing these symbols. It's sort of like an operator telling you what to do. And so I came up with an antiderivative. Oh, shoot. Is that the question?
No.
Yeah, I don't think that's the question. I think the question is, come up with a general antiderivative. Or how about this in English? Come up with all antiderivatives for the function integrand's position. I think for that reason, I need to tack on that constant of integration. Does everybody agree? Having said that, what can you guys possibly say about up in this exponent by 1? Up in this exponent by 1, what do I get?
5x plus
5x plus 3 to the...
3. Well, wouldn't you use the math B skills to first break it
Why
down?
not do it their way?
Because we don't have use substitution yet.
What's the use of it? I don't know what that is.
Wouldn't it be a lot easier if you just FOILed that out and then did the anti-differentiation?
It's not going to be a lot easier. I just think as of today, I have no choice. You guys
Okay.
think about it. I've done nothing wrong on the middle board. It's just that to undo the differentiation process here, I've raised my exponent by 1, divide by the new exponent when the input, or excuse me, when that independent variable is x. I think in this particular example, I'm supposed to anti-differentiate with respect to s. It's just that what's being raised to the second power is more complex. So here I do think it's an example where I want to use my math D skills first. Here I do think I want to come in and expand that binomial square. Oh, you guys are in deep, deep REM sleep. We can do this. I know we can.
30x
plus 9.
Now you have to confess, with respect to that variable s, which by the way is my variable integration, is something nice and clean being raised to second power within this first term in the integrand's position. So here I do think it's legal. No tricks, you guys. I really can anti-differentiate with that power rule. I will up my exponent by 1 and divide by the new exponent. Here too, I will up my exponent by 1 and divide by my new exponent. And likewise at the end, I will just simply list that antiderivative, which is nothing more than
9x,
And
or
then-
s, is plus c.
yeah, I make constant integration. You think I made a mistake? Just double check me. Take that beast at the end and differentiate respect to s and see if you get what's in the integrand's position.
So would you be happy if we left it like that, or do you want us to put it all in one fraction?
You know, I just think if you put it to 1 fraction, it looks so cumbersome. I mean,
Yeah.
at least here I recognize that I've got a second degree, or excuse me, a third degree polynomial expression. I can clearly identify what the coefficients are. I think this looks much better
Okay.
than trying to find some kind of common denominator with those coefficients.
So I don't know if they're equivalent, but the back of the book has a different answer.
What do they have? Ooh, how interesting. You know, technically speaking, what the book has done right in their answer, they've used a version of something called the substitution technique. Okay, can I just show you what it is? You know, I take a peek at this integral. You guys, I took my glasses off. Help me with this. 5s plus 3
Yes.
squared.
Yes.
Now, I have to confess, this kind of really does look like something clean being raised to second power, but sometimes when I want to, I force the issue of making what's in the integrand's position look clean. One way to do that is dive in and simply take this complex base, this 5s plus 3 business, and give it an easier, cleaner name. I mean, at least that way, you guys, in the integrand's position, I've got something that looks nicer being raised to second power. It's just that sometimes that ds, what I refer to as my flag to which I pledge my allegiance, everything has to be in terms of variable s. Oh, shoot, it's not. So I have to change the flag to which I pledge my allegiance. One way to do that is to differentiate u with respect to s. And you guys, with this particular choice of u, what can you say about the derivative of this u with respect to s? I agree. You know, sometimes I like to rewrite that as a du in terms of ds, which is nothing more than 5 of the ds's. And that being the case, you take a peek at the integram. There's a symbol left over, ds, right over here, but I think another name for ds, according to this substitution, is going to be what times du? I
du
agree.
divided by 5.
And so I'll write the 5 over here. I think, however, that's nothing more than a 1/5 times the integral of u squared with respect to u. And yes or no answer, you guys. This is an absolute piece of cake to anti-differentiate. Yeah, I agree. I'll up my exponent by 1. Divide by the new exponent, and I'm left with 1/15 u cubed plus my constant integration. But you guys, it's sort of like somebody asked me this question in English, and my first language is French, and I had to translate in my head to my more common language, and I'm working on things, and all of a sudden I have to give an answer back. Sure thing, I give the answer back in English, aren't I? So I think by a mathematical etiquette, I really do need to back substitute. So rewriting this in terms of my variable s, I've got a 115 times a u to the third, plus my constant c. It's just that the old name for u was, oh, here it is, the 5s plus 3. So help me with this. Is that what the answer has as the answer?
Yes.
For the
Yes,
alpha?
yeah.
Got it. Well, he put the whole thing over 15, means the same thing. So just a different way of looking at it. And you guys, if you think I made a mistake, I mean, how could you check these two answers to see if they're the same? Just
Back-
one.
or you multiply 5s plus 3 cubed out and then divide by 50.
Yeah, expand the darn thing. And just check it. Oh, you know what, you guys? I didn't think it checks out. Actually,
Yeah, that's the problem I ran into.
yeah, if you think about it, if you raise this thing to the third power, let's not do this too much work. But certainly the very last term, isn't that going to be a positive 27?
Yeah.
Oh, divided by 15, shoot, and I don't have a 27/15 over there. What happened?
It's
It's, well, see, I think what happens is this. When you look at that 27/15, there's a constant being added to another constant. And that constant plus this constant is just simply that constant over there. So it doesn't look the same, but they are indeed equivalent mathematically speaking. Are you there? You guys don't want to take too much time tonight on homework. What's next? Is it
81.
81? So taking a peek at 81, I've got a flow rate. A large tank is filled with water, and then an outflow valve is opened at t equals 0, but the water flows out at a rate given by this function. And this is going to be the outflow of the water for a period of 10 minutes. So, find the amount of water QT that flows out of the tank after t minutes and given with the initial condition, the initial value condition, that Q is 0 is equal to 0. I don't know, you guys, any ideas?
Anti-differentiated.
All right, how about this as an idea? Listen to this thought. To come up with the function Q at t, what do you say we just take everything above the squiggly line and differentiate it?
No, you have to anti-differentiate it
Why can't I differentiate?
because it's already differentiated.
Because it's already differentiated. And if I differentiate it again, you guys, wouldn't I come up with a second derivative for Q? And if I come to the original function Q, what I really want to do is undo the differentiation process. Are you with me?
Yes.
All right, if you are, can I give myself some room? Q is 0 is equal to 0. Let's anti-differentiate term by term. I think the constants get pulled out of the anti-differentiation process. However, anti-differentiating the first time in my term in my parentheses, I get a...
100t
I agree. What about the second term?
minus t cubed over 3.
T cubed over 3, I agree. Are you happy?
No, because there's no constant.
Good. And if I'm going to anti-differentiate, I need the constant integration. But I don't like it.
Do you put the constant outside of the parentheses?
Huh.
Because you're differentiating what's
What a
inside
good
the
question. I don't
parentheses,
know.
right?
It's up to you. I mean, you really could put it inside the parentheses. It's just that if you did, then I think 1/10 times that constant c is just going to be another constant. If I
Oh, okay,
decided to remove
okay.
the parentheses, I think you have choices.
So it's okay in this case to anti-differentiate within the parentheses and not multiply it out?
Yeah, here's why. Because I think when it comes to anti-differentiating a function f in terms of x that's being multiplied by a constant, this is nothing more than a constant times the antiderivative, or the general antiderivative of function f with respect to x. Just like with the differentiation process, those constants get pulled inside and outside of the integral process.
But the last problem we had, are you saying that that's not complex just because it has 100 minus, like there's no variable?
You know what, I just didn't understand the words, I'm sorry.
In the last problem, we had something that was semi-complex that was being raised to a power.
Yes.
How is this different than that?
Dramatically. Because I think what's being raised as second power, for example, here is something nice and clean as a single independent variable t.
Term within the term.
And I also think what's being multiplied on the outside is just a constant, it's not another function in t. And so when it comes to just constant factors or constant coefficients, I can pull them inside and outside the differentiation process, as well as pulling them inside and outside the anti-differentiation process, since the anti-differentiation process is reverse of the former. Oh, you guys, we messed up. To be honest with you, I want a particular function q. I don't want this plus c garbage. So how can I just take a break and find the value for c?
Set it all equal to 0.
Set what equal to 0? Okay, then.
Well,
Equal to 0?
set q of t equal to 0, and then just get rid of anything that's multiplied by t on the inside, because
So
t is equal to 0.
0 equals 1/10 times 100t minus 1.
Well, 100 times 0, so you don't even have to put that
Oh,
in
so
there.
what you're saying
Yeah,
is
you're just going to multiply it by 0, so 0 is going to equal c.
No, I like
Right,
that.
yeah.
What you're really saying is this. With this initial value condition, this tells me when t is equal to 0, q is simultaneously 0. So I think I need to substitute in for q of t and t as well as values of 0. And I think that leaves me with this. I'm writing too much, you guys. So let's just- But that merely means that c is equal to... Yeah, I agree. So I think the particular function I have for q is going to be my 1/10 times what's inside my parentheses. If I can write it. Plus my constant c, which I just found in this particular case to be 0. Are you happy? Go over hands. You guys, there's something I missed. Wasn't there a number 32?
32 and 5.1.
Yeah.
Oh, 511. So 511 number, I've lost that already. You said 32.
I was wondering, is there only one way to write these, or because I was thinking there's multiple ways I could have written some of these answers.
What do you mean?
Well, like I could have used subtraction, I could have used
Yeah.
addition, I mean,
No, I see your point. I see your
yeah.
point. And I have to agree with that. So you guys, let's take a peek at part A where I've got 1 plus 3 plus 5 plus 7 plus this dot, dot, dot nasty notation. You know, I don't like this dot, dot notation. And so maybe you and I can come with a more concise closed form notation to represent the 6 on. And I think using my summation notation. Well, actually, that's my next question. I mean, where does n start?
0.
1. 0, 1. Which one?
1.
See, I think you have a choice. I don't think there's one answer. I think it's entirely up to you what you want to allow n to start at. And I think the key, before I even put in that number to the right of that equal sign down below, I need to identify the pattern involved in this particular sum.
I put negative 1. for where it
That's
starts.
even more interesting. You start at
Yeah.
n equals negative 1, that works just fine. So, help me with this. If on the x-axis, I had values of x like 1, and then 3, and then 5, excuse me, I misspoke, 1, 2, 3. And I had y values that were 1, and 3, and 5, and I plotted these points. What can you guys say about this parabola?
It's not a parabola.
Where?
It's a line,
How do you know?
because,
like that.
Because every time I jump from one position to the next, something is happening over and over again. I keep adding 2 to the previous item. So I think what's going on is I've got a line whose slope is basically 2. So I just think naturally, in terms of what this nth term looks like in here, is going to be something like a y equals mx plus b. Sorry, in this case that would be y equals 2n plus b, or how about question mark? And to figure out what question mark is, got to start somewhere. If n is equal to 0, then I think the very first term has to be positive 1. When if I plug 0 in for n, what will question mark have to be so that the first term is positive 1?
0?
I think it have to be
1.
positive 1.
Oh.
And Brad, if you start at n equals 1, now the question, or excuse me, if you
Negative
start
1.
at n equals negative 1, now the question is, what would that question mark be so that this whole thing is equal to positive 1?
Well, when I started at negative 1, like I was using k here, but
K
I'd
is-
do,
yeah, that's fine.
I'd do k plus 2.
What do you think the largest value for n should be then?
49?
Where'd you get
99.
49? How do you know it's 49?
Oh, okay.
Because I used logic to figure that
Oh,
out.
you just watch. How about saying this? You guys watch. Call it pound symbol.
Okay.
However, when n is equal to pound symbol, is it not true that I'm going to generate that very last term? Ah, shoot. Now, solving this math A question for pound symbol, I'll just subtract 1 from both sides. Divide both sides by 2. Does it give me a
49.
49? So I did that very last value for pound symbol, or for the n, excuse me, is going to be positive 49. That's what generates the last term.
What's the question mark if n is equal to -1?
Well, sorry, I'll backtrack. He was saying he wanted to interpret the sum as n range from -1 up to somewhere. It's just that if you allow n to be equal to -1, how on earth are you and I going to generate the very first term? I think to generate the first term, question mark has to be something for which, when I plug -1 in for n, I generate the first term. So pulling up my piece of scratch paper, doesn't that mean 2 times n plus question mark, where n is equal to the first value I'm holding down there, has to be equal to the very first term of the series. And now just being lazy, solving for question mark, just give me this. I'll add 2 to both sides. I'll pick up 3 off the ink board, substitute it in for question mark, and if you think I made a mistake, just double check me, see if it matches up with the very first term. And when I plug -1 in for n, I get 2 times -1 plus 3 is, oh thank goodness, that very first entry. It checks out. You feeling better than homework?
Couldn't do n plus 2, start at -1.
You know, if this expression were n plus 2, I'm kind of nervous for this reason.
I just don't, I wouldn't start with negative, I'd start with 0 or 1.
Yeah. Because that's what I did. I started with -1 and I just did n plus 2.
That makes sense too, though.
You mean like this?
Yeah.
Oh, let's see if it works. If n is equal to -1, what does this get? What does this give us?
1.
Oh, thank goodness. But if I plug -1, the next value for n, which is 0 in for n, what do I get?
2.
Ah, shoot, that's not
Crap.
2.
All right.
Do you see my point?
Yeah,
Natalie?
yeah.
And so I think here you have to sort of like take a walk. For every one increase in some independent variable, I'm looking at a corresponding increase in 2 values in these entries in my series. That's why I think it's acting like a linear expression of the form y equals mx plus d. Better? So do you guys agree I can't do this?
Yeah.
Okay.
Is it always going to be mx plus b? Or is it that's just how it
Cheapers,
will-
no. I think the pattern could vary dramatically, and we'll get a much better handle on that in Math 31. Actually,
tonight?
I take that back. I think we get even a much better handle on Math 33. Just give me a few seconds. Oh, you guys, I have so much to discuss tonight. I really want to set ourselves up to study